Here we go. Volume. It's our second to last lesson of the quarter. How about that? You may have been exposed to volume before. If so, good. A couple formulas today. And with volume, you can think of it as the space inside a 3D object. Could be the amount of liquid inside of a can of soda. Could be the amount of Cheerios inside of a box of cereal. But it's space inside of a 3D object. That's what you're measuring with volume. And the first guy we're going to talk about is a prism. Now, prisms come in different shapes and sizes. And the reason why is because it depends on the base. But the bottom line with the prism is the volume is going to equal big B times H. And you might be like, wait, a big B? What's that? That's different from the other day with base times height. So this is base times height, but the big B stands for area of the base. And this is different because it's basically two problems in one here. The base is a unique shape, okay? Unique shapes such as a triangle, a trapezoid, a rectangle, a circle, okay? So, if I was to have a classic box or cube, my base could be my bottom. My bottom, what's it called? My bottom of the shape. That'll work. Now with a cube, okay, in your brain, how do I think of this? Is if the shape were to grow straight up, do I have like this situation? So if this box grows straight up, it becomes a taller box, yeah? So that's how I kind of think of, oh, that must be my base. Because of that, I could pick the front. If the front were to grow, it would still become like a bigger box. I want to compare that to a triangular prism, which is slightly different. So a triangular prism looks like this. So with a triangular prism, I know the triangle is the base. Why? The guy right across from it, it has to be the same. So with the prism, if my triangle were to grow up, I still have a triangle on top. With this shape, if I were to say, oh, well, I want to use the front for my base. Well, if this rectangle were to grow, I should have another rectangle behind it, and I don't. So with the base, with a prism, you're always going to have one unique shape on bottom and one unique shape on top. Like the same unique shape. So the same unique shape, two triangles. The same unique shape, two rectangles or squares. If you were to do a trapezoid, I think it's called the trapezoidal prism. It's like a bar of gold. Just like all my bars of gold at home. I'm kidding, I don't really have bars of gold at home. Okay. Your base is going to be the shape that is on the front and back, or the top and bottom, or the side and side of your shape that are unique and identical and in the same configuration. Well, you have a trapezoid in the front, and you got yourself a trapezoid in the back. Okay, that's your unique shape. Those are your bases. Okay. Now, so we talked about bases. Those are our big B's. And I'm not going to lie, you are going to want to watch the examples video for these ones. Because the examples video for these ones are going to make these guys make more sense. Because these guys can be tricky. Now, height. You might be like, oh, Mr. Maxson, that's easy. It's just top to bottom. Well, with this one, we have a base on, like, the between what's it called? The space between the bases is the height. That's true. Top to bottom, that'd be our height. Height would also work there. But right here, would I use this height or would I use this height? Use this height. The h with the volume is the distance between bases. Okay, and we're using a big B there. Bases, like the trapezoid, triangle, triangle. So height doesn't always mean up and down. If the shape is tipped over, I mean, like, look at this. Oh no, I tipped this over. Am I using this for height? No, I'm using the distance between my base. Okay. So again, we're using the same terms, base times height, but we are meaning different things, and you need to recognize that. With volume, all of a sudden you're flipping to 3 dimensions. Okay? 3 dimensions have length, width, depth. And again, please watch the examples video, because I will go through some of these problems together with you guys. And in my opinion, watching these problems done, you're going to be like, oh, okay, I can do that. That makes sense. And that's the goal. That's where I need to get you. And some of you guys might be already there, which is great. The other formula we're going to talk about is a cylinder formula. And that is extremely like a prism. Okay? And you might be like, well, why don't you just call it a circular prism? That's a good question. So a cylinder is like a can of food or a soda can. And the volume is pi r squared times the height. And you might be like, well, Mr. Michelson, pi r squared is the base of a circle, or the area of a circle. And I'd be like, yeah, you're right. You know why? That's the base. Remember, the base has to have the same shape on top and bottom. Those are your bases, guys. Boom. Your circle grew up, and now it's a cylinder. There you go. But that is extremely like this one here. Prism. Volume equals area of base times the height. Cylinder. It's the area of the base times the height. It's the same thing as this guy, but we are using a circular prism, if that were such a thing. A circular prism is called a cylinder. Whenever you name a prism, guys, you name it using the base. So this guy would be like a rectangular prism, a triangular prism, a trapezoidal prism. Okay. Anyway, there you go. Make sure you have a calculator when you're doing this guy. We got our friend pi back, 3.14, or the pi button. All right, make sure you watch those example videos, and I will see you in a moment.